Hello students, welcome to this session on the topic electrochemistry. So in this session the subtopics covered will be Kohlrausch law and its significance and determination of equivalent conductance at infinite dilution for weak electrolyte. So the importance of Kohlrausch law lies in its application. So Kohlrausch law is applied in the determination of equivalent conductance at infinite dilution for weak electrolytes, determination of degree of dissociation of weak electrolyte, determination of dissociation constant of a weak electrolyte, determination of solubility of sparingly soluble salts, and determination of ionic product of water. So it has got many applications. So now in this session, let us see the first application, that is determination of equivalent conductance at infinite dilution for weak electrolytes. So in case of weak electrolytes, the equivalent conductance cannot be determined directly. So at infinite dilution, its equivalent conductance can be obtained from the values or knowledge of equivalent conductance of strong electrolyte at infinite dilution. Suppose if we take example of acetic acid, which is a weak acid, a weak electrolyte. So the equivalent conductance of it at infinite dilution can be obtained from the values of equivalent conductance of strong electrolytes HCl, sodium acetate and sodium chloride at infinite dilution. So according to Kohlrausch law, the equivalent conductance of acetic acid at infinite dilution will be equal to sum of ionic conductance of acetate ion and ionic conductance of hydrogen ion at infinite dilution. So if we consider this equation to get an idea, so sodium acetate plus HCl to form acetic acid and sodium chloride. Now if we take equivalent conductance of acetic acid at infinite dilution, so it will be equal to equivalent conductance of sodium acetate plus equivalent conductance of HCl minus equivalent conductance of sodium chloride at infinite dilution. So applying Kohlrausch law, so this will be equal to equivalent conductance of acetate ion at infinite dilution, ionic conductance of sodium ion and HCl. For HCl it will be ionic conductance of H plus ion plus ionic conductance of chloride ion at infinite dilution. For sodium chloride, it will be ionic conductance of sodium ion plus ionic conductance of chloride ion at infinite dilution. So after removing the bracket, it will be minus lambda naught Na plus minus lambda naught chloride ion. So here ionic conductance of sodium ion will get cancelled and ionic conductance of chloride ion will get cancelled. So remaining is ionic conductance of acetate ion plus ionic conductance of hydrogen ion at infinite dilution. So the sum of which will be equal to equivalent conductance of acetic acid at infinite dilution. So by knowing the values for strong electrolytes, we can calculate the equivalent conductance of weak electrolyte, that is at infinite dilution. So it is also called as limiting equivalent conductance. So if we take example for acetic acid, so the equivalent conductance at infinite dilution for sodium chloride is given as 126.45 into 10 to the power of minus 4 Simon meter square per equivalent. For HCl, it is 426.16, whereas for sodium acetate, it is 91.0 into 10 to the power of minus 4 Simon meter square per equivalent. So these are given values, that is equivalent conductance of strong electrolytes at infinite dilution. So now, as we have seen earlier, this can be calculated by the equivalent conductance of sodium acetate plus equivalent conductance of HCl minus equivalent conductance of sodium chloride at infinite dilution. So substituting all these values, we will get the value of 390.71 into 10 to the power of minus 4 Simon meter square equivalence per equivalence. So this will be the equivalent conductance of acetic acid, a weak electrolyte at infinite dilution. So let us take another example, that is the determination of equivalent conductance of a weak electrolyte, that is weak base ammonium hydroxide at infinite dilution. So it can be calculated from the values of equivalent conductance of strong electrolytes of ammonium chloride, sodium hydroxide and sodium chloride at infinite dilution. So according to Kohlrausch law, so equivalent conductance of ammonium hydroxide at infinite dilution will be equal to ionic conductance of ammonium ion plus ionic conductance of hydroxide ion at infinite dilution. So to get an idea, if we take the reaction, ammonium hydroxide plus sodium chloride gives ammonium chloride plus sodium hydroxide. So equivalent conductance of ammonium hydroxide at infinite dilution will be equal to equivalent conductance of ammonium chloride plus equivalent conductance of sodium hydroxide at infinite dilutions minus equivalent conductance of sodium chloride at infinite dilution. So from Kohlrausch law, we can write this as ionic conductance of ammonium ion plus ionic conductance of chloride ion at infinite dilution, plus for sodium hydroxide, ionic conductance of sodium ion plus ionic conductance of hydroxide ion at infinite dilution minus, so for sodium chloride, it will be ionic conductance of sodium ion plus ionic conductance of chloride ion. If you remove the bracket, it will be minus ionic conductance, that is lambda naught of Na plus minus lambda naught of chloride ion. So here lambda naught of chloride ion will get cancelled and ionic conductance of sodium ion lambda naught Na plus minus lambda naught Na plus is cancelled. So remaining will be lambda naught of ammonium ion plus lambda naught of hydroxide ion. So that is the sum of ionic conductance of ammonium ion and ionic conductance of hydroxide ion at infinite dilution, which will be equal to equivalent conductance of ammonium hydroxide at infinite dilution. So knowing the values of equivalent conductance at infinite dilution for strong electrolytes, we can calculate for weak electrolyte.